The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
This talk that I'm going to give is going to be an overview about how to keep slab level. Basically, it's based on some litigation cases that I've been involved with. I'm a structural engineer, been about 30 years or so. In the last 15 years or so, I've been asked to participate in basically forensics. They run some problems and they say, can you help us look at this? And so it's a sure. So I've probably done a couple dozen cases, mostly in concrete, slab cracking, some waterproof issues, but several with deflections or unlevelness of floors, and so that's going to be the top what I'm going to talk about here and kind of share. I'm not going to share in detail some of these because we've only got 20 minutes, but I'm going to tell some of the general lessons that are out there. I think we've allowed you guys to recognize them, and then what can we do as ACI to kind of head this off. So it's going to be simple. I'm going to tell about some problems, and you've kind of seen them, and some causes, which I think we know about as well, and then some solutions that I think we can do as a group to get away from them. So the problem is this. There's several modern buildings that I've been involved with on the West Coast that have experienced deflection issues or out-of-levelness issues and have resulted in expensive litigation and unhappy owners, I guess unsatisfied owners first. And so that's the problem. So it's what happens. I mean, you get a call. I mean, I know some of you guys have done some of this as well, but you get a call, and it's usually 1 or 2 years later, or maybe 3 years, and there's been issues with these floors, and they've tried to work it out between the parties, and finally the parties are going no dice, and so it goes into litigation. They file the suit, and they call in all the experts, and so we go in there, and we measure these floor slabs with detailed survey. We do all this back analysis, and we do concrete cores and petrography, and we look at the concrete, we look at the test results, and so we gather this data, and then we get it together and argue about it. And so I'll show some of these basic slides in these ACI tables that we've had to try explain to lay people. Sometimes us engineers argue about what the L is for the distance or what this L over 360 means, and we can't agree, but we try to explain it to some attorneys and insurance company representatives. And so when it's all said and done, they're kind of like, okay, well, everyone's at fault, and who's got the most insurance, and let's get out of this thing, And so that's kind of the reality of what it is. But so I've been in depositions and heard the contractors and engineers and other experts talk about these things, and I'll share some of these issues that have been dealt with. So the 5 projects that I've been involved with, there's 2 are post-tension concrete flat plates. I've had bad deflection issues. 2 of them were traditional concrete 2-way flat plates with just the rebar. One was a concrete slab and metal deck, and matter of fact, it was a hospital. It wasn't the same one he talked about, but the same kind of thing. But I'm not going to talk about that one, but the same issue with communication I'm going to talk about just is the same thing that we'll talk about. And 3 of the projects had excellent engineers and contractors, and that's what kind of bothered me, frankly, is these engineers. I knew a couple of them, and I've dealt with them, and they're solid, they do good buildings, and the contractors are reputable, and these things happen. And it's kind of like, whoa, And you listen to testimony on both sides, and frankly, they both did their job to an extent. And the problems are not new. And I'm sure a quote here, and this is a quote on a letterhead of a pretty prominent structural engineering firm that's in this country. They're not a 5-man shop. They got offices in several cities. They've been on some of the projects. I've looked at them, and so this is a quote from one of their letters when they've reviewed this, and they're saying, "We don't do these just reinforced flat plates anymore because," and I've talked to them. They say, "We've been sued too many times." In other words, it's tough to get these things right. Architects push them, and these things end up moving, and then, boom, they get hammered. So that's a reality. It's not new. I've done some, literature research. You can find in there that, there's one paper that the people have done load tests, and they're saying that some of the effect is not adequately covered in our current code approaches for deflection and calculation control. And I'm going to agree with that statement. I'll tell you why later. Here's a quote from the Structural Journal, 1999. His title of his talk is Deflection Calculation for Reinforced Concrete Structures, Why We Sometimes Get It Wrong. And he said here the ACI 318 is inadequate in some situations. And I agree with that. And he says this is particularly the case for sensitive elements such as floor slabs. So it's been around, and you guys have talked about it as well. I see four causes in these ones I've been with. Design, there's design issues that you can not be aware of. Codes, and particularly when we talk about is you rely on ACI 318 alone, and you can get hit. And construction, and I think there's we've talked. People know this loaded in slabs and shorings and that kind of stuff can happen in too soon and too not cured concrete. I think that's cause an issue. And lastly, there's owner's expectations. I think we can work as a group to address that as well. And that's a huge issue. And again, this has already been talked about, but it's kind of reinforcing the same theme I think we've been hearing today. I'm going to take one moment, too, and talk about definition. And the definition is two things, floor deflection and floor out of levelness. And I think Bruce hit it, too, when he said there's deflection and there's tolerance. So, and the owner doesn't care. I mean, he comes in he's got 2 years later, and his desks are rolling, or his gurneys are rolling, or his drawers and his thing are open, or his cracks up there. I mean, he doesn't know if that was out of tolerance built like that, or if it was moved afterwards. And so it's easy, even when these experts are talking in testimonies, people get confused that, it's deflected, it's moved. And so I think it's clear to keep those separate and to try address them separately and measure them separately. So the issues with design that I've seen is when you stretch the envelope, i.e., we're pushed to make this thing thinner. And the variance with the slab deflection calculations goes exponentially when you start making these things thinner. That's just one thing. Relying on tables, even on the minimum thickness table, I've had the guys testify, well, it made that table, so I don't need to check anything, and it's fine. And the owner's going, it's not, I don't like it, And CAN programs, some of these programs are getting pretty sophisticated. But, even the normal engineer, I guess, when you're asked to testify against the other professions, it's a tough deal, but you're asked to gauge them against the normal standard of care. And the standard of care is that an engineer should understand that what this program is doing. It can do a sophisticated time-dependent analysis, but you better know what algorithms are using or have an idea, or else do sensitivity studies to understand it. For example, I've asked them, I said, look, they said, well, this program gave it to me, and I used these factors. I said, okay, but, at 3 feet away from the column, how was it calculating the crack section? What was your crack section at that location? No, I don't know. I mean, it's inside the program. Well, how do you know that they did it right? We bought it, we paid for it, and industry likes it, so therefore I'm off the hook, So that's understanding what you're doing is important. In understanding of construction tolerances, you've all talked about ASI 117, and designers need to know what to expect so they can communicate that and tell them to the architects and the owners. Communicating expectations early on. And I'm going to talk about this communication, and I'll jump ahead and say that it's really great when you've seen this, like these guys this morning from San Francisco. They had this team, and they talked about and worked it out, and even from Chicago, where they can work these things early. Some of the projects we deal with are public work projects. They're designed, and they have to be publicly bid, and so there is no communication up till it's hard bid. And that's the industry we have. We need to be able to address, i.e., the lack of communication at that point, and it's our specifications, and let the owners know what's going on up front. And that's on the design professional to bring that to light, understanding what can happen. If you got a team environment, it's a lot easier to deal with that because you can work at it. And the last two is reality we see out there is competitive design fees. Let's face it, I mean, we got great firms that do stuff, and they got firms that are 10 people that are competing for them, and their fees are 60% less, and they're getting the jobs. It's a real issue, and they don't have the time and expense to go to look at every slab, every location, and I mean that's just part of our industry. And then pressure to produce cost-effective structures. I think we've all seen that. We've seen that trend in our industry, so that's part of the design time. Also, I've seen in the design, some designers will not tell about this time to removal of shores, and also to communicate the structural deflections. I mean, a couple of their speakers talked about how they share that, and they talk about it, and it's great, but it's highly controversial. Some people say, no way, man, that's means and methods, and our insurance company won't let me tell that, work with those. And that's, they deal with the issues of their carriers, and so I think we need to say that has to, I mean, ACI 347 will quote, says that we should be doing that, and I would think that needs to be an issue that needs to come out, and it has to be part of the communication. I don't know how we enforce communication legally, but we need to work at it. So, you've seen this table several times, these minimum thicknesses, what's the L distance? This table's been there, and it's been talked about, there's no total thickness in there. And then you got the IBC table that's out there. And when these things go to litigation, these attorneys say, well, okay, what is the standard? Well, legally, it's the building code, which is in our part of the country is the IBC. They adopt the ACI 318, so here it is. And all these other manual standard practices, which are great, they're not legally bound to do it. So then you go to these things and you try to explain, well, this one applies here, and this one applies here, and I met those, and it's just, I mean, you guys have seen it too. It's pretty gray, and we could do some suggestions to clean those up a little bit. And then lastly, if you use ACI, you got this table that people read, and several of the guys here said, well, ACI 435 has these other ones that say this and this and this. That's more reflective reality. But you can go back and say, well, I did this, and the code says that. So, I've seen those conversations. This table in the code needs to have a great big asterisk by it, and then explain when it's applicable and when it's not. So, as I mentioned, 435, it's a good reference document, but not so widely used. I think the average engineer may or may not have access to this, and if they have access, do they read it? And some of it's technically complex, and their fees don't allow them to, do the extra work in there. It talks about variability in there, which is great. This e-value of 80 to 40% difference. I think there's should be more discussion in there, saying, guys, this is reality, and be watching for it. And Bruce said he'd like to see deflection calculated as 2 inches plus or minus an inch for these flat plate slabs, rebar slabs. If you go beyond a half inch, I say half inch increments, that's about what you can get at from a tolerance standpoint. PT slabs maybe go less than that because you can get closer on those. But when you even in depositions, and someone's calculating 1.42 inches versus 1.78, like he said, both numbers are right. That's Eamon said he had two calculations. One was 100% off, and both are right. And how do you explain that to an attorney? That's pretty interesting. So we've talked about ACI 117. You've seen this, and I think that's good. I mean, when you talk about these things and explain, you got to go through these different standard practices with these lay people, and you can show them kind of what the background is to try to prove a point, but it gets pretty convoluted. Now, the last one, this code ACI 302, it has been talked about. There are some guidelines in there if you want flat floors, and actually they say FF and FL, you can have certain things to go there, and they give some relative FL numbers, and I think this is a good direction, and I think this could be expanded on, i.e., and also to get them after the shores are pulled. Now, long term, in 5 years, what should we be expecting? I think that's the direction the industry should be heading. We should be able to work together as a team, even specifications to get there. So 302 is not too bad. And it even talks about, again, this for suspended slabs, these FL numbers, which is the big ticket here. And And one of them, to get higher FL numbers, you do a topping slab, basically. And that's their codes and guidelines. In construction, I think they've talked about tolerance of floorings, vertical deflection of floorings, tolerance in placing and finishing. There's people talked about that. And the understanding of structural deflections. We see good contractors that maybe they put their B team on the project. And these aren't 50-story buildings. These are 2- and 3-level buildings that are, for universities and stuff. They're good contractors, but maybe they don't understand the ramifications of this. And that's what happens. And a lot of times, as mentioned, they got contractors 2 concerns. He's got the strength, so he can, get on that slab and move his shores, and then he's got speed. And how that slab moves or not, that's not as big an issue, and I think we just need to make that as big of an issue, or maybe even a bigger issue. And 347 does mention in there, and it's a guideline that the criteria be specified by the architect engineer. You got to go there to find it. And I think that should be also documented clearly in other areas. So then talk about owners' expectations, and most owners don't. They go into this pretty blind. I mean, one case, there was this hospital owner that had real specific criteria, but most of them just kind of expect they're getting a normal building, that when they walk in, they get this building. And architects, we still see the 1/8 inch or 1/4 inch and 10 foot. And if you can't get it with slab, you put topping on there. And architects kind of get, these flexion heads. But I think it's critical that we as an industry work towards make it a real requirement that we somehow document to the architect and owner, and then if the contractor's on board, here's what's going to happen, and here's how we get there. So I'm just adding this in here. It's kind of what I've seen in my work. I've both the designer and seeing this is in your parking garages. It's all based on what people typically see. And if you have 1.5 to 2 inches in these 30-foot bays or garages or quarter longer, you can have longer deflections. That's usually okay as long as it drains. Retail, if you get plus or minus inch and a quarter. In offices less, in hospitals less. And condominiums and special labs can be even tighter criteria. And some of those require topping slabs. I've also, in practice, several times we've designed, especially we did a lot of PT buildings that are these retail or condos and housing. And we would measure floors. We'd have the contractors give us survey measurements. We'd go out there with a laser level and check them. And I just had a rule of thumb that if I designed for the long-term deflection, I would say for these buildings at 3/8 of an inch, I'd go out there and measure it, and I'd get 3/4, plus or minus. And that from that column to that column might be high. ACI 17 allows you to be off a little bit, but in between, my long-term deflections with the field tolerance size is about double. If I used a half, I was getting about 1 inch, plus or minus. That was kind of a rule of thumb I used, and I told my younger designers to stick with these ranges. That's not a code issue, but that we need to understand that. It's also critical that when we talk about these levels of flatness that we can obtain, that we tell the owners we can do this, but it's going to cost, and we should be able to get at that. And it's normal construction practice. Without doing a lot of stuff, you can get in that 3/4 to 1.5 or this L over 300 range, with 240 range probably in those, without a lot of issues if you're careful. And the tighter criteria, as I mentioned, you got to use topping slabs, unless you're really, really good. So that was some of the causes and the problems and the causes. And the solutions are, I'll just try to kind of run through these. There's no different high points here, but these are general. I'm going to talk about just the creep factors in ACI. We need to have some kind of warning in there that, watch out, guys, if you're doing two-way flat plates or sensitive issues, that these can way different. The creep and shrinkage, you should refer to 435 or do something different. To really highlight for the normal engineer that this is somewhere you got to be careful about going to. These guys that have talked today, I think they recognize and get it. There's some things we've seen in this creep, and I don't know. I've done some research, and maybe someone can speak up here. The creep behavior. This research I've seen is most of the tests have been done like a long time ago, 30, 40, 50 years ago. They've done all these creep things, and it's been in the code for a long time, and these numbers are there. I don't know if there's these modern cement grinds, and if I haven't looked to see much if you get high stresses. You stretch the envelope and you get higher stresses if the creep is jumping up or not, even on the long-term stuff. I've seen evidence point in that direction. Also, when we've done a petrographic analysis on several of these buildings, we've seen signs of microcracking, and that typically can be due to a number of causes, and it's, after 5 years later, you can't really say, but there seems to be a trend there, and there's not a lot of research and publications on microcracking, but we suspect that some of its early age, even in post-tensioning. I mean, if you're stressing out 3 days and ripping those shores down, reshoring, and your slab is stressed and it's going, you also get bending moments to the dead load that are fairly high. You try to balance these slabs. If you got 3,000 psi, but it's still fairly green, and you're close to the MORs, you get some microcracking that may end up affecting that E. We found these, use petrographic and do tests and find this variability in ease and compressive strength in these areas. So that's something that might need some help. And then that language in ACI 318 talking about the variability, I think we should add something in there, and along with those charts. And then 435. And I think we need to move towards allowing FL for elevated slabs after shore removal, and then there's ways to get there. And document expected and rational FL numbers, and of course the means to get there. And I don't know whether this can be done through an 302, because that's a good place for it, or a separate document maybe generated to kind of combine a lot of this information to present it. So, and then lastly, some mention teaching and getting it out there to everyone. So, that is the summation of my recommendations. So, I guess in summary, these deflection issues we've seen, it's not widespread. I mean, there's hundreds of buildings built that people are doing the right thing, okay? But there's some honest mistakes out there that have happened. And people are shaking their heads, and it's kind of giving the concrete industry a black eye, which in my opinion. And we need to be aware of it, and we'd address them. And, frankly, in a couple of these attorneys are asking me, so did this designer screw up? I said, well, he followed ACI 318 legally to a T. And the contractor followed these specifications. He says, well, so who do we blame? I said, well, you can't go sue ACI 318. They ain't got any money, but they're doing it honestly, I think, is what or maybe not knowingly. So that's my summary.